Hi, this is Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS, Rajalakshmi College of Arts and Science, Coimbatore. In this video, we are going to discuss about the graphical solution of linear programming problem. Before that, how how we find the solutions of a given LPP using the graphical method, what are the various steps involved. So the major steps in the solutions of LPP by graphical method are assumed as follows. The step 1. Convert the inequality constraints as equations and find coordinate of the lines. Step 2. Plot the lines on the graph. If the constraint is type is either less than or greater than or equal to type, the solution's zero line away from the center. If the constraint is type is greater than or less than or equal to type, the solution 0 is towards in the center. That means the constraint is less than or equal to type, the solution zone lies inside the region. If it is greater than, the constraints zone lies outside the region. Step 3. Obtain the feasible zone. Step 4. Find the coordinates of the objective functions. That is a profit line and the float on the graph representing it with a dotted line. Step 5. Locate the solution point. Step 6. Solution type. If the solution point is a single point on the line, take the corresponding values of x1 and x2. If the solution point lies in the intersection of two equations, then solve x1 and x2 using the two equations. If the solution appears as a small line, then the multiple solution exists. If the solution has no confirmed boundary, the solution is said to be unbounded solution. So now we consider the following example. Solve the following linear programming problem by graphically. Maximum visit is 6x1 plus 4x2. Subject to the constraints 2x1 plus 3x2 less than or equal to 120, 2x1 plus x2 less than or equal to 60 when x1, x2 are positive. First step, we consider the coordinate points. We convert all the inequality as equality from the constraints. Here the problem is maximized and the constraint is less than or equal to type. Therefore, the solution region lies towards inside the region. So from the first line, we make it the inequality as equality and find the coordinate points 0, 40, 60, 0. From the second equations, we find the coordinate points 0, 60 and 30, 0. So we float all these points on the graph. We get this type of graph. And here, suppose we consider this graph is on the graph sheet. So we take the x1, x2 as positive. Therefore, we cut the line using by the scissor on line x and y. And that means x is on x1 axis, x2 is on y axis. We cut that, we have a positive coordinate axis. And then we cut the first line. We have two regions, one is outside and inside, but the first inequality is less than, therefore we consider the inside the region. And cut the second line the same, the inequality is less than or equal to type, therefore we get the inside the region. In total, we have the shattered region as shown in the figure. We call it as it is O, A, B, C. The coordinate point of O is 0, 0. Coordinate point of A is 0, 30, 0, and the coordinate point of B we don't know. Coordinate point of C is 45, 0, 45. So we find what is the coordinate point of B. This point is intersecting of line 1 and 2. Therefore, we solve the line 1 and 2. Then we get the point we get the point x1 and x2 as 60, 30, 15 and 30. So we substitute all the point in the optimum. 6x1 plus 4x2, we get z0 point is 0, z A is 180, z B is 210, z C is 160. So among this, the optimum is maximum. So among this, all the points, we consider the maximum value of z is 210. So its coordinate points are 15 and 30. Therefore, the maximum z is 210 when x1 is 15 and x2 is 30. We have one more example for this. Here, all the constants are greater than or equal to type. Therefore, the solution region is outside the region. First, we consider the coordinate points using these above three inequations as equations. We get this type of coordinate points: 0, 10, 2, 0, 0, 6, 6, 0, 0, 3, 12, 0. So we float all these points and we denote the solution region as A, B, C, D. A is on x-axis. It is on x-axis A. B and C we don't know, but these two are intersecting of the given lines, and D is also there. But it is greater than or equal to type. The solution region is outside the region. It is unbounded. So we solve the equations and find the values of x1, x2. Then we calculate what is B coordinate and C coordinate points, and to put it everything as we get a maximum value. Here maximum is finally we get the maximum value to the constant coordinate points. Therefore, the maximum z is 3x1 plus 3x1 plus 2x2. The coordinate point of A is 12, 0. We get the value become 36. The coordinate point of B is 4, 2. The value is 16. The coordinate point of 1, 5 of C is 13. The coordinate point is 0, 10 of D is 20. Therefore, the maximum z is 13. Among these, sorry, it is not maximum, it is a minimum. So minimum is 13 when x1 is 1 and x2 is 5. So we have one more example for is a combination of less than and greater than constraints, but problem is minimum. So we as usual find the coordinate points, and to put it all the points in the line, we get this type of graph. Then it is the graph is, the region is as shown in the figure, is A, B, C, D. The coordinate point of A is 15, 0. Coordinate point of B is 40, 0. But we don't know what is C. It is intersecting of two lines, and we don't know what is D. It is intersecting of another two line. Therefore, solve that line equations. We get some points. Then put it everything in the optimum. Then the problem is minimum. So among these all the values, we identify which one is minimum. That is 240 when x1 and x1 is 6 and x2 become 12. That's all. Thank you.